this is Lori and welcome to my series on the Pico W. This is part 12 in the Exploring LED Displays videos. In this episode, we're going to be working with the MAX7219 driver chip and driving an 8-digit 7-segment display. Here's a picture of the 8-digit 7-segment display that I'm going to be using in this episode. And you can see the MAX7219 driver chip here. Now, I was a little surprised that this driver chip is also used for 7-segment displays. I had run into this chip because of these kinds of displays, and I've used this before, and there it is right up here. That's the chip. And so I thought it was primarily intended for these 8x8 LED matrices. And if you read the data sheet, it shows mostly the example of connecting up these 8-digit 7-segment displays to it. It can control 64 LEDs, so it's going to work in both cases, but we'll have to obviously program it a little bit differently depending on which display we're going to use. You can see here in the pinout that here's the digits. So it's even described more as a 7-segment display driver than as an 8x8 LED matrix. And then you can see the segments are controlled right here, all the way to the decimal point. So there's our 8 segments that we would have in our display. And over here you can see the chip connected up, and we're going to use SPI to communicate with it. And we need to connect to our Pico 3 of these pins. And you can see here I've got a couple of them, and so this is the side that we would connect directly to our Pico. And so we'll need to ground and power it, and then we'll have this data in pin, this chip select pin, and a clock pin. So 3 pins that we need to connect into our Pico to get it to work. So let's take a look at that circuit. Here's the circuit we'll use in this episode. Fairly simple. We have the 5 pins on the display to connect, and you can see that we have power and ground, and then we have the data in, the chip select and clock pins. They need to come back to pins on our Pico, and the data in and clock pins need to come to SPI capable pins. So the data in pin needs to go to a TX pin, MOSI, maybe I shouldn't say it that way. And then the clock pin needs to go to an SPI clock pin. And then we have the chip select pin. I chose to put this one on 17. I think you could put it on any digital I/O pin you want. And then you can see this is the kind of MicroPython code that we would write to set up the SPI bus. And here we have to specify the clock pin and the MOSI pin. So, and then you can see if I'm cascading them, then it's a straight direct connection. This one, when you flip this LED display, it'll say data out, and you plug it into the data in of the next display, and you could keep cascading them. I don't know whether there's a limit or not, maybe just your patience. But then one thing I think that needs to be discussed is just I'm taking 5 volts off of my Pico here to drive this. It worked fine for what I was doing. But if I was setting this up permanently, I would definitely power this separately from the Pico. I wouldn't use the Pico, so it might be just overwhelming the Pico there. So we could set up a breadboard power supply, especially if you're going to start cascading multiple LED displays and potentially using like all of the digits at the same time. I think it would be a good idea to power it separately. So I think that covers the circuit. And now let's start talking about the libraries we have. These are 3 libraries that I found to drive the 7-segment displays. The other MAX7219 drivers I found were intended for the 8x8 LED matrices, which, the functions and so forth wouldn't be very helpful in trying to put numbers on the screen. So these were ones I found that worked with the 7 segments. The first two here I didn't actually use because I was very interested in being able to chain or cascade these displays. And the only one that appeared to have that functionality was this one by Genesis. So that's the one I went to try to try to drive that. So let's take a look at that library. I just put up some of the code that I used to test out the Genesis library here, just to point out the different kinds of functions it has, methods, I guess. And so you can see just setting it up here. Here's how you set up the display object. You tell it how many digits are in each display, so that's 8, and then I have two displays together, so the total number of digits is 16. And here you can see telling it what SPI bus I'm going to use. And this reverse thing is, I guess, depending on how the digits are wired in, which one's digit 0, which one's digit 7. So for these displays, reverse equals true seemed to be what I needed to use. And here's the number method we can put a nice number on here. So use that one. And here we go. There's a letter method. So I can tell it what position I want, and then I can say what character. So there's a built-in character set. So you can use letters and numbers and a few symbols that are built in. It has a really nice message method that allows you to scroll a message. So do you want to play a game? We can scroll, change the scrolling speed. So how about a nice game of chess? So we'll take a look at that. And then we can also just use the text method, which will put the text on the screen and not scroll it. So Lori's Robots will fit on the two displays. So that the text method would work for that. So let's go test that out. All right, let's put the Genesis library through its paces. We saw some of the code in the slides I just presented. I have the two displays connected up over here, as you can see. And, we'll set up our SPI bus, our chip select pin. Then, as we saw before, this is how we create an object to use with the library. And we tell it how many digits there are on each of our displays, and then the total number of 16, what SPI bus we're using, what chip select pin we're using, and depending on how your display is wired, you may need to put it in reverse order. I did too. That seemed to be the default in the library. And then this is one of the things I ran into that I was a little surprised. I thought I should be able to display pi out to this many digits, even on just one display. But I find that it rounds it and only displays 7 digits when there's a decimal point. So I thought, geez, I should be able to display this with two cascaded displays. But again, it truncates it. And then I tried playing around with other numbers just to see if moving the decimal point around made any difference. But it does not. It's only going to show 7 the way it's programmed. But if there's no decimal point, you can put on a number that will go through all the digits. So here's a 16-digit number that will display. Then we have the letter function that we talked about briefly. We can say what position and what character we want to show. And now we're using a character that's then going to be looked up in this dictionary that's included in the library. So you can see here this file here is imported into the driver, and here's all the characters that we could use. So quite a few. Some of them are a little strange, as you know from trying to put a whole alphabet and symbols on a 7-segment display. It doesn't quite work, but yeah, so you can do that. So I'm displaying the number 1, but I'm giving it as a character here in the third position on the it'll be on the first display. And then we can scroll messages. So do you want to play a game? And how about a nice game of chess? And we'll go a little faster so we can control the speed. And we can also use the text method when we don't want to scroll the text. We can just put the text in like this, and this Lori's Robots will fit on the two displays, so it'll just show Lori's Robots. And then we can clear, there's a function to clear the display, so clear it out. And I used it here. I mentioned that if you're going to use this letter one, you need to clear it out from the last, the last one. Clearing is important with this. Let's see. All right, so I'm hoping you're going to see the problem that I had with this library, and that is that it echoes whenever you send something in. On the second display, you get some echo from the first display, some ghosting, I like to call it. So hopefully you'll see that as we go along, and that plays into the project I want to do, and pushed me to learn how to use the MAX 7219 chip myself rather than through a library, so that I could make my project work the way I wanted. But let's see what happens when we use this demo, and hopefully you'll see the flash. Yeah, so we get to the next one, it's going to flash right there. And so you can see the two numbers. This one also gets truncated. Here's the full number. There's our letter method. And here comes the scrolling, which works really well. And I don't see any echoing in this one. So I think the scrolling method is working appropriately. I haven't spent a lot of time looking at how the scroll works, so definitely something I'll probably spend some time with eventually. Yeah. So that works pretty well. So you might have noticed in these messages, these are two messages from a movie that I saw when I was much younger, called War Games. I really loved that movie at the time, and I recently had a chance to see that movie again. And I got inspired to make a project after watching that movie with these 7-segment displays. And so I hope you'll enjoy this project, and I hope maybe you've remembered this movie. It's really great. So this is my project. You might remember in the movie, if you had a chance to see it, and if you haven't, you really should. You should go see it. There was this computer that was going to control all the nuclear missiles that the United States had, taking humans out of the picture. And then, of course, the computer goes a little mad and starts to try to launch all the nuclear missiles. It was called Whopper. It's hilariously funny. And here's the countdown as it's trying to find the launch codes. So right before it's going to launch them, it's seeking out the launch code so it can do that, and it's searching through them. And these digits are moving slowly as it tries to figure out what the actual launch code is. And this one here is what the launch code actually is. So I wanted to replicate that scene where the digits are flashing by randomly as the computer's trying to find the correct digits. So it has 3 digits here that appear to be letters, then 4 in the middle that are numbers, and then 3 more that are letters. At least that's how I programmed it. So now you can see here it has the final code, but I wanted to kind of create that simulation where it starts off as though it's searching through all of these characters to find the code. So that's what I wanted to do. So let's see what happens when I program that using the Genesis library. All right, so just to make sure you understand what I'm trying to do, especially if you haven't seen this movie, I thought I would show you kind of the ultimate program that worked the way I wanted to. And I'm going to run the program that I finish off the next episode in, because this is just going to be a long video otherwise. So I'll show you what I'm trying to do using that program, and then we'll go through how I did it in the Genesis library, and you can see the issue I have with that ghosting in this particular project, and what drove me to learn how to use the driver chip on my own. So let's close these files here so we have a little more space. So we'll just do this. So we're going to be searching, the computer Whopper is searching for the code, the code to launch the missiles. And as it gets, and it's going to get the code going from left to right. So it finds the first character, it finds the next character. Now, this is just a simulation. It's not actually finding it. I'm just sort of simulating it finding it. So it's going to randomly put letters or numbers in the correct spots as we go along, acting like the computer is searching for the launch code. So that's how it'll progress. So let's just see what it looks like when we run the program. So there we go. So now it's sort of randomly putting up digits and numbers. It's searching to get the correct code. As it gets each one, it moves on to the next spot. And then once it gets that code, it moves to the next one, and then the final code is up there. So that's the idea of what we're trying to do. And so now we'll go through how I programmed it, because even with the Genesis library, the basics of the program itself are pretty similar. It's just writing to the display that changes. So let's go through the logic of how to do the launch code sequence simulation. And we'll set everything up as we have before, creating our display object here. Since we have two, we have the 8 digits per display, a total of 16. And the first thing we're going to do to do this simulation of the launch code discovery is we'll need a list of the letters in the alphabet, and we'll need a list of the digits, because we're going to randomly sample from these to create random codes that will be displaying on our displays. We'll need a couple more lists, one with the final code in it and one with the current code in it, the current randomly selected code. And then what we'll do at the very end is we'll have a randomly selected code, and as we move along, we'll take part of the final code and then the rest of the random code and put it up on the screen, put it up on the display. So that's the whole idea. I hope that makes some sense. Not sure I said that very well. Well, the first thing we'll need to do is loop across these 10 digits. So that's what the outer loop is doing. And we'll need to select a random letter for 6 of them and a random digit for 4 of them, the 4 in the middle. And to make it look realistic, we don't want it to find the correct code for each position in the same number of loops. So let's pick a random number of loops. So we want it to go a certain amount, so it looks like it's searching, but maybe not too many. And this is something that, you could change and make the simulation last as long as you wanted. Probably should have these as variables in the future. And then we're going to loop over. So now we're working on a particular position, setting it, and we need to create the random code. So here's where we're going to work through, create the random code, either picking letters or digits. And then to make sure that we don't, as we're doing these random number of loops, that we don't pick a random number that's the actual correct number in the code, we need to keep looking and choosing until we get one that doesn't equal the actual code. Because you wouldn't want the actual code to show up and then you flip to the next code and you're like, oh, I thought we got it. So you have to check and make sure you don't pick one of those. And so I found that the easiest way to do it was just with this while loop. So it just checks and makes sure, and it won't move on until it gets something that's different than what the final code is for that position. Then we'll put together what we're going to put on the screen. I call that the print code. So we'll take the part of the final code that we need, that we've already found, and then we'll add in the random code on that loop, and we'll get ready to display that. Now, when we get to the very end of this, we need to make sure that the final code gets put up on the screen. So this looping system I have here is kind of like loop too short. So that's how we make sure that we end up with the final code at the end. And we'll insert some blanks because there's some blank spaces in there. And I kind of hope to take these displays and sort of get them butted up together. So we'll actually need a space where we don't use one of the digits as well. It kind of looks a little funny the way I have it right now, but when I actually do this project, I'm hoping to use my laser cutter to make a nice enclosure for it, and I'll want it to to position those digits just so they look like they were in the movie, maybe as close as I can do with my designing of the enclosure. So anyways, we need to insert those spaces into the print code in the right places. And then I have a little, as I was debugging this loop and understanding, how to make it do what I wanted, I had this little print statement. So if you want to watch how this loop works, this is a great little print statement. Uncomment that and you can watch it go by. And then here we're sending the print code to the display. And we'll make it go pretty fast, so there'll just be a short delay, so this will look like it's moving very rapidly. And we'll show the final code for 30 seconds, and we'll go ahead and clear the display. So I think you'll see why I moved on from this library, and but it does work. Yeah, so here we go. So it's kind of just like the one I previously showed. It's working its way across the digits, finding the correct code. And you can tell, but you can see the flashing here. It's actually flashing what's right here over here. Not in this digit, but in these, and you can see it a little bit in the other digits too. So, that's what pushed me to try to learn how, because maybe I could debug the library, but since I didn't understand how to work with the chip, I couldn't really look at the library until I learned how to code the chip myself. So then I just decided I didn't want to mess with somebody else's code. I just decided to write the code I needed to do this project. So I didn't need to replicate all the functionality in this library, just the pieces that I needed to do this part. So in the next episode, that's what I'll cover, is how I went through learning how to control the driver chip, and I definitely had a lot of help from some YouTubers who have done that, and how to read the data sheet to understand how to send commands to the chip. So I thought I'd go through that and show the process that I went through to learn that, and then we'll see the the final code simulation run again. But I hope you'll join me for that next episode. And as always, thank you for watching.